So the question we are trying to answer is, suppose we know that y1t is x2t, y2t is xt over 2. The question is, if one of them is periodic, does it mean the other is periodic? Okay, so let's first work on the continuous time first. Let's first work on the continuous time first. So if you look at the first question, so the first step, y1 of t is going to be what? It's going to be whatever your x of t is, x of t, your y1 of t is going to be horizontally compressed or stretched. Which one is it? Is it compressed or stretched? It is stretched. It's It's compressed. So therefore, the first one is going to be faster. So this is y1t, and the second one is slower. y2t. So therefore, one can see that if the first one is periodic, then the second one will also be periodic, but with a smaller period. The second one will be periodic with a bigger period. Vice versa is true. If this one is periodic, xt will be periodic. If y2 is periodic, xt will be periodic. So it's true for all the combinations. So far so good. Let's now look at the second one. The second one is actually a little bit harder. Why this is harder? The reason is the following. If you look at this expression, first you should notice that why we are not using directly this. Why we are, because if you compare these two, the correct, easier expression should be y2n is xn over 2. So why we don't do that instead of we have this longer expression? Is the question clear?
Yeah.
Why do we want this? This is bad, obviously. This is good. Why we don't want this?
Well, because in the continuous one, whatever t is, like that's your t, but in the discrete function, whatever in the brackets is your t, so that changes.
Close. For example, what is really the problem? For example, what is y21? If I'm using this expression, what do I get?
It's equal to x of 1/2.
X of 1/2, which is a bad expression, because this is a bad expression. Anything inside the bracket has to be an integer. That is why in this expression, we actually separate it into two cases to avoid to avoid having this like that. You can sit in my chair.
You're right.
So that's why we don't like that. Okay. But it's okay here because there's no such problem when y11 is going to be x2. It's still an integer inside. So that's the first difference between this and that. Okay. So now let's to understand what's really going on, what we need to do is to really figure out what does y1 look like. We want to look at what does y1 look like. To do that, let's start from x of n. Let's give an arbitrary x of n. Just an example. So this is, I just create an example arbitrarily. Suppose this is my x of n. My question is, how would you plot y1 of n? How do you do that? Okay, how do you plot y1 of n? If you look at that, what is y10?
Whatever says 0 for x.
So I'm going to copy this one, and then I'm going to replace it here. That is how I got y10. How about y11?
Oh, it's at 1/2.
No, y1. Now let's look at y1. y11, what is y11?
What's it? X of 2.
X of, no, it's not, there's no t here. What is y11? Right, so let's go back a little bit. The question we are trying to answer is, suppose this is my x of n. The question we are trying to answer is, how do you plot y1n? Is the question clear?
Yeah.
This is x of n, want to plot y1n. What is y10? I copy this value and place it here. You got it perfectly. Is everybody following? Now the next step is, what is y11? How do I find y11? The formula says what? y11 is
x at 2 times 1.
which is x2.
Okay.
Is this everybody following? So therefore now, look at this figure. What should I do?
The negative.
I copy this one, and now I'm placing it here. Is this part clear to everybody? Okay, let's try one more. y12. y12 will be what?
x4.
x4. So I'm copying this guy, and I'm placing here. Is everybody following what's happening? You can repeat this. How about y1 negative 1?
Be the
I copy, let's say, this diamond shape, and then I'm placing it here. Okay. So now we can think about what exactly is this operation from x of n to yn. Basically, what does it do? It removes anything in the middle and then compress them so that they place them together. That's basically what's happening. Removing anything, because you can see those will never be used. Removing everything in the middle, the odd positions, and then place the rest of them closer together. That is how this operation is. Is this part clear to everybody? So once you realize it, now the question is, if x of n is periodic, does it mean y1 of n periodic? Is this true? If question, is this periodic? Again, think about what is really happening. This operation is what? Removing the odd positions, compress them together. If before this operation is periodic, after this operation, is it periodic or not?
yes.
Answer is yes. Perfect answer. Is everybody following this part? Because you can see, before I do that, it's periodic, it's repeating itself. Now all I did was what?
Remove the odd.
Remove the odds, place them together. It should still be periodic. That is how we know the answer is yes. Everybody is okay so far?